Awesome. Thanks for coming in, everyone. Quick introduction as you come into the Cloud Datastore 101 session. I'm Dan McGrath. I'm the product lead for Cloud Datastore. We're lucky to have today with us another speaker, Phil Keslen from Niantic Labs, who will come up and give us a little talk about how Niantic Labs uses Cloud Datastore. So what I want you to leave here with today is an understanding of what Cloud Datastore is and in what situations you would use it. I also want you to be able to walk out of here and just have an idea of how you would be able to talk to it from your programming language of choice, and also see how you can integrate into the other parts of the Google Cloud platform as part of a holistic solution. And as I just mentioned before, once we get all that out of the way, Phil will come up on stage and give you a real-world example, literally a real-world example, of how they used it in the launch of Pokémon GO. But before we get into all that, I wanted to give you some background context of tasks that you typically have to do when you're running a database, particularly a database at scale. So there is a lot of background infrastructure work that you need to set up. Most of you would already have this set up now, but it is something you need to think about. Everything from shipping in your infrastructure from the back of the truck to setting up the air conditioning and the network on your rack and stack. And then as your server is running, you need to think about ongoing maintenance and eventually upgrades to that system. All this is time that you could be spending on working on your application rather than your application's infrastructure. Once you've got all that groundwork set up, then you've got the joy of picking out an operating system and working out your upgrade and patch schedule, which hopefully you're doing as new security vulnerabilities are detected. You're upgrading your operating system continually and working out when your scheduled downtime is to make that happen. Once that's out of the way, you can finally start thinking about your database and working out which database version works with which operating system version that you have, looking at the patch schedule that you have for the database and when you want to roll that out, and whether you can roll patches out online or whether you need to take your system offline to apply those patches. And so at this point, now you have your database up and running on an operating system that you're maintaining, on a hardware stack that you're maintaining. You haven't quite finished there. Now, the last task that you have is thinking about high availability. How do you make sure your system will continue running when you have a regional outage? And how do you scale that system? As your application grows or gets unexpected traction, what are you going to do to add new capacity to your database? Oh, and I forgot to mention, there's also monitoring of this entire stack. Everything from what's happening with your aircon system. Is your operating system appropriately patched? Are there operating system alerts being issued? The database itself, is it out of date? All that sort of stuff is things that you're going to be carrying, or someone within your organization is going to have a pager for. So with that context in mind, I want to let you know I am not promising that Cloud Datastore is going to solve all of these problems for you, but for the right use case and the right workload, it will put you in a position where you don't really need to think about the database that you're running. You're just able to use it as part of your application. Now, Cloud Datastore is just one of the database offerings we have within our managed database and storage portfolio. It's really as our managed NoSQL database for user-facing data. Sits in that non-relational space. The other option there is Cloud Bigtable. If you have relational workloads, we have the option of Cloud SQL or Cloud Spanner. We also have everything from object storage, persistent disk, Google Cloud Storage for those blob is the object storage I mentioned. And then if you're using App Engine, you do have that hosted Memcache solution. All of this can be pretty overwhelming trying to work out what is the right database solution for you. So I wanted to give you a bit of a cheat sheet of some quick questions you can ask yourself to work out what is the right database for me. Perhaps it's not Cloud Datastore. For me, hopefully it is. So the first question I want you to ask is, Are you working with semi-structured or structured data? I think this is a really quick pass. You'd be surprised how many people would end up using the wrong solution here. But if you've got unstructured data, really look towards cloud storage. And if you do have unstructured data, don't try to force it into a database. The next question is really understanding what is your primary use case. Is it transactional data or is it analytical data? If you're really looking to do analytics as your primary workload, you should be looking at something like Bigtable for Internet of Things device data, or BigQuery for that more traditional data warehouse that scales. The last question you really need to think about before you get to Cloud Datastore is it relational data? If you're doing a lot of complex joins, you should be looking at either Cloud SQL for that lift and shift model of your traditional MySQL or Postgres instances, or if you're looking for that massively horizontally scalable SQL database, Cloud Spanner is the right solution. If your answer to those questions are no, then Cloud Datastore is a really good hands-off, no-ops, non-relational data source that you can use. So what I want to do is then, once you've got that out of the way and you're thinking, OK, Cloud Datastore looks like it could be a pretty good solution for what I'm doing a mobile or web application. I don't really have DBAs on staff, and I just want to launch something that I don't have to think about. Cloud Datastore can really fill that fast, fully managed solution that will literally scale with zero downtime. It will do everything from serving your data from a single machine, and then as you scale up, will go to tens of thousands of machines. We have many customers who run multi-millions of requests per second against the system without having to worry about configuring the replication system or worry about how many nodes they have to add to it. To give you an idea of the scale that it operates at, early last year in 2016, we were already serving 15 trillion requests per month. So you can do some quick math and work out how many requests per second that is. The last thing I just want to mention is this is not an untested solution. It's been used by our customers in production for 8 years and is also used both internally and externally by Google software. Some example use cases, these are the sort of typical workloads that we see people using Cloud Datastore for. The first one, and this is by far our biggest use cases, is user profiles on mobile and web applications. If you want to store something that has a flexible schema, that you can continually iterate on what type of data you're storing about the user without having to worry about schema changes, Cloud Datastore can be a really flexible solution for that. Since we don't force you to have a schema, you could just add new fields as you need them. The next one is, and I'll talk about some of the functionality that helps with this later on, is catalogs and any sort of hierarchical data where you want to logically structure stuff together. So if you're thinking about doing review sites where you have items that you want to have reviews on, and that is a good example of hierarchical data that you can store with us. And the last one is durable state for games. Working out what inventory players have, where items are around the world. You'll typically have a lot of that cached in memory, so you can do very low latency serving. But because whether you're using pods in Container Engine or traditional VMs, these things will eventually crash, and you don't want to have that state lost. Now, with some of the features that you get with Cloud Datastore, the first one I wanted to point out, even though we're a NoSQL database, we handle non-relational data, we do have some of those features you traditionally want within a database. So the first one is multi-document transactions. You can do transactions across multiple documents in the database. It's not just read and write and then hope for ACID compliance. The second one is we have really good support for secondary and composite indexes. We have some limitations in there that are designed to make sure you design your system in a way that scales, but we will allow you to do multiple equality filters and inequality filters on those properties. And the last one, and this is something I think we don't talk about enough, is it is automatically replicated across multiple zones and multiple regions without you having to manage anything. It is literally a one-click setup when you set it up, and then you don't have to think about that again. And the last one, as you would expect from most Google databases, everything's encrypted at rest in transit as well. And this is using the same encryption technology Google uses for all our products, like Gmail. And then to quickly finish off with the features, I wanted to give you an idea of some of the basic building blocks that you have to create your application. So you have the laundry list of data types that you'd be looking for, everything from booleans, integers, down to blobs. You have some slightly more advanced stuff you can use with arrays and embedded entities. To use a non-Google term, embedded entities you can think of as just maps that you store within your data. And up here, I just wanted to give a quick example of hierarchies and how you would have that stored. So you may have something like a user in your system, and then under that user, you would have a bunch of orders that they've done and perhaps a list of billing accounts for that particular customer. This hierarchy and how it structures has implications on whether you have stronger eventual consistency and the right throughput for your data. If you want to know more about that, there was a technical talk we gave yesterday called Building Scalable Apps on Cloud Datastore. So you can look at that on YouTube, and it will tell you more about the details of how that affects consistency. When I originally set up to do this talk, someone asked me, could I do a presentation on setting up replication, multi-region replication? And I decided it shouldn't be a talk by itself, and I'll just put it in here as a couple of slides. So the first step to setting up multi-region replication within Cloud Datastore is going into our console after you've created a project and clicking on Create Entity. So right now we only have one database per project. We have IAM permissions you can assign to it. So you can assign either ownership role or user role, which is read and write, or read only to the database itself. So you can control who has access to it compared to the rest of the project. This is also used as the default database for App Engine. So if you're using App Engine, this will also provision the default database it will use. So step 1, click on Create Entity. Step 2, it's going to ask you where you want to put your instance. Now, this is where you get to choose between multi-region, which is that multi-zone, multi-region replication, or just regional replication. The second choice as part of this drop-down is about where do you want your data to be located. You can pick North America with US Central or US East 1. You can pick Europe with our EU West multi-region instance, or you can pick Tokyo, Japan for a regional instance. And that's it. That's why I didn't make it as a separate presentation. The moment you make that choice of where you want your data located, you are running a multi-region replicated service that is running 5 replicas across 3 independent network fabrics. So let's talk about that a little bit more, and what does it really mean? So I've already mentioned you can pick multiple locations to have your data stored in North America, Europe, and Asia. We also have points of presence located around the world. Now, a point of presence is an egress and ingress point to our network that goes onto the private fiber optic we have, so you can have low latency access to wherever your compute or database resources are located from anywhere around the world. When you pick between regional or multi-region, the 2 different options of replication we have, it does change what the SLA is that we offer. So if you pick a multi-regional instance, it's 3.5 nines. If you pick a regional instance, it's 3 nines. Now in practice, our systems actually operate above those levels, but that's the guarantee that we give for those systems, because regional outages do happen. So if you really can't afford to have your application go down when a region goes down, we highly recommend you pick the multi-region solution. The other difference to keep in mind, and think about why you might pick a regional location. One is location. If all your user base is, say, in Japan, then perhaps you'll want to have the Tokyo, Japan instance, because then it's co-located with your users. The last one is write latency. Because we synchronously replicate across regions, you will have slightly higher write latency on a multi-region instance. Now, the last thing that I'm going to talk about when we look at regional replication and multi-region replication is this quick visualization on the system, just so you can understand how we're structuring this under the covers. And this is a very simplified version. So this is an example of US Central, where region 1 is Oklahoma, region 2 is Iowa, and region 3 is South Carolina. So we do 2 full replicas in Oklahoma, 2 full replicas of your data in Iowa, running in separate zones. And then we have a third one that we call a witness that essentially acts as a tiebreaker if one of these regions go down, that's located in South Carolina. Now, all of these are connected together by 3 fully independent fiber optic networks. So we can have a network down for maintenance, we can have a backhoe go through another one, and we can continue to serve all your traffic at full capacity. Now, I won't go too much into the weeds with consistency, but I think this is an important thing to note. Depending on how you work with your data, we support both eventual consistency and strong consistency within the system. Now, the easy way to think about this is if you're using us like a key value store, so if you're just doing gets, lookups, and writes, we're strongly consistent because we will synchronously replicate that data across our network. You get eventual consistency when you're using our indexes, because the indexes themselves are eventually consistent. And that's how we sustain throughput regardless of how many indexes you write. There is one caveat to that, and that's if you're doing a thing that we call an ancestor query, that is also strongly consistent. And ancestor queries are when you're querying within one of those single hierarchies, those single entity groups. So if you co-locate your data, we can guarantee a strongly consistent query in that particular case. To give you a little bit of background on why this matters when you're designing your system, there are many use cases where you absolutely require strong consistency, and there are some use cases where you would prefer scalability and write throughput than having to worry about slowing down for strong consistency. So the example I wanted to give here is if you're doing a social networking site, it would be really unfortunate if you have a post about someone's surprise birthday party that you delete, and then you add that friend to your social network if they can still see that post about their surprise birthday party because of eventual consistency. That's a pretty basic example of why you want strong consistency in situations like that. Strong consistency is all about making sure that multiple people and systems get a consistent view of the database at the same time. Now, there are definitely places where eventual consistency is completely applicable as well. So a quick example here is if you're doing a census population of an area, it can be very hard to do a strongly consistent count of everyone in, say, the United States, because you've got to work out when do you count a birth, and there may be minutes difference between them. Now, if you're off by a couple of people when you're looking at 300 million, it's not such a big deal. Or if you've got a gaming review site, if you miss the last update from one user that happened 5 seconds ago when you display the list, it's not such a big deal. So with some of the fundamentals out of the way there, I wanted to quickly go through some of the multiple ways that you can talk to Cloud Datastore. So we went GA with our new client libraries and our new API last year that allows you to access it cross-platform. Previously, we were only part of App Engine, and now we have a way to access it, whether you're calling in from your on-prem solution, from App Engine, Container Engine, and Compute Engine. The languages that we support natively using our Google Cloud client libraries are Java, Python, Go, Node.js, Ruby, C#, and now we have PHP as well. These all have a very consistent interface, so when you're switching between languages, it should still feel like you're interacting with the same database. If we don't support a language that you're interested in, and typically I'll get questions around things like C++ or embedded devices, we do have a RESTful API that we document, so as long as you can do HTTPS calls and you know how to handle OAuth, you can connect to it from any modern programming language. The last part of that is we also support gRPC. So the underlying API infrastructure is gRPC. So if you want to do that streaming low latency request, you can also use that. I did mention before that we were originally part of App Engine, and we do have a rich ecosystem of SDKs or frameworks that you can use that we've developed over the years. So over the 8 years, we've had a variety of different solutions you can do. But one I would point out for Python, if you're using that, is something we call NDB or NextDB, which is a full framework, integrates in with Memcache, task queues, as well as Datastore. We also have some third-party ORMs that people have developed that are really popular within our customer base. So if you're using Java, there is something called Objectify that a lot of people use on App Engine, and there is also a client library for PHP. Okay, so we've talked about programming languages, we've talked about strong consistency, we've talked about the basic building blocks and the underlying replication that you get with the system. Let's look outside of Datastore now and talk about some of the products that we integrate with. So there are everything from data warehousing to export your data if you want to do complex standard SQL queries, to Dataflow if you want to rapidly fan out across the data, either writing it in or reading it out to integrate into other parts of the system is available. And as I mentioned before, you can call us from any of the compute services that we have. So let's quickly look at how we integrate with cloud storage. We have a backup or an export tool that you can call that will do a full dump of your data. You can optionally give it a specific subset by either kind, which is sort of like table name, or namespace, which is a way you can separate your data. We will write that into an export format that you can use elsewhere, but I just want to point out it is in a level DB format, which is an open source database that we released in 2011, so you can write any of your code to read and write into this format if you want to do your own fancy thing with it. When you have an export in cloud storage, within BigQuery, you can use that as a target to ingest into your system. So this is how you get your data warehouse experience. A lot of people we find do daily dumps of their data, so they have a full history that they compare to the system. Cloud Dataflow, which is Apache Beam, it's our execution environment for Apache Beam, is a really good way if you want to do those massive fan-out reads. You can use this as both a source and a sink within the system, and you can auto-scale the system up. So depending on whether you want to get it done really quickly or you want to save money using sustained discounts because it runs on Compute Engine, you can control how fast this happens. We typically see people using Cloud Dataflow to do live ingestion into BigQuery rather than going through that full dump. But we also have people integrating it into things like PubSub so they can push messages out into other parts of their infrastructure. And the last one I wanted to quickly point out here is StackDriver monitoring. So we are integrated into StackDriver, and there are 4 key metrics you can look at. You can look at the overall request rate that you have in your system. You can look at the average and standard deviation on read and write size, so you can see if anything's changing in your system, and you can also see what sort of fan out you're having on index writes. And that's important just because indexes are eventually consistent. That level of fan out affects the time frame of eventual consistency. You can also set all sorts of alerting on this. So if you want to get alerted when your production traffic is spiking way above what you're expected, or if you want to set alerts when it drops to 0, which indicates some part of your system has crashed, you can also do that. So with this basic introduction of Cloud Datastore out of the way, I want to invite Phil up onto the stage to talk about how they used it at Niantic Labs.
Thanks. Thanks, Dan. So a little bit of history about our company. We actually started out inside of Google. Ingress, which is our first product, which we launched in November of 2012, was originally built on App Engine. And at the time, Datastore was the only storage repository that we had available to us. Given the long history of Ingress, which is 4.5 years old now, we have a great deal of experience in how to effectively utilize Datastore, and we utilized that knowledge when we delivered Pokémon GO. Some more insights about, if you don't know much about these games, they are real-world MMOs, massively multiplayer online games, and they are location-based. So some of the key features of this is we have to have a consistent state for all of our players. All the players are seeing the same game board in the real world. They see the same gyms in Pokémon GO. In Ingress, they see the same set of portals. They see interactions with the portals. Actually, Ingress is significantly more sophisticated than Pokémon GO as far as gameplay goes. So we needed a solution that would provide us with consistent state for all the players, a mechanism to get scalable real-world mutations for both game and player state. Game updates are done periodically. I don't know how many of you actually play Ingress, but we add portals to the game, so an ability to regenerate portions of the game, adding new features to it on the fly without taking the game down is necessary, and for that we use Dataflow. And then the last one is that players are always moving, so you're always going to have hotspots in your data. We needed a mechanism and a scalable solution that would allow us to get to that kind of gameplay. This is a kind of a rough flow for how our system is architected. We have the mobile client, which has a cache of the current game state. It's continually querying the servers for more information about the changes in the game, especially when the players are moving around. It really only has a small view of the world at any particular point in time. The server consists of a player service and a backend spatial service, which manages the world. Currently, it's actually not running on this. At launch, we were running on tens of thousands of CPU cores with a data store capable of handling the load that we were seeing. And I'll go a little bit through that launch in just a minute. So one of the reasons we chose Datastore, and Dan highlighted this, is the engineering team for Pokémon GO on the server side consisted of 4 people. And if you saw the stack on the side, I have absolutely no employee base to manage a data center and a database. Somebody asked me the other day, it's like, why didn't you just deploy a Cassandra instance? It's like, well, because I'd have to have 2 people. Half of my engineering team would have to manage that Cassandra instance, and they would have to scale it once we launched, which would have been, in my opinion, a nightmare. So we chose Datastore because it offered us a very inexpensive solution to our storage problems. The launch of Pokémon GO, I think everybody's kind of aware of what happened there. We launched on the 5th of July to New Zealand and Australia. And everybody has asked me, why did we pick those 2? It's because Australia and New Zealand, we figured at peak would represent about 4% of our total user base. And with the Play Store and primarily the App Store, you can only do country-level deployments. So this was the way, by doing country-level rollouts, was the way that we controlled traffic into our system. And at launch on the 5th, within 6 hours, we had exceeded our expectations by 2.5x, using 4% of the total world's of the population that we've expected. So needless to say, when we pushed the button on the 6th to launch in the United States, we were kind of on pins and needles. And this is the magical chart. When we originally provisioned the system, we ran our load tests, and we came up with what we thought were just wildly unbelievable estimates for how much traffic we would see. We used existing MMOs, what their user base was, how big the traffic numbers that they were seeing, and we said, okay, let's just take that number and multiply by 10. That's a nice big number, and that's the red line, and that's what we gave to and then we modeled that in our system, and then that's what we gave to Dan as the number of the amount of QPS that we would throw at Datastore. The first day after we launched New Zealand and Australia, we sat in a meeting and we tried to figure out where we thought this graph was going to be, and the number we came up with was 30 times our expectations. And in the end, this chart it still goes. we stopped it. But it actually gets bigger than that. But it took us a while to actually get all the resources in place in order to enable the scaling that happened. And for that first 2 weeks, we had a lot of bumps along the way. I'll go back to this slide. You can see the big gap between the US and Germany. That big gap existed because we couldn't get everything in place in order to support the additional users that we were going to throw at it. And then we went with Europe. We went kind of rolling push through Europe, and then into Canada, back to the US, primarily because people have to sleep. At least we thought they did. They actually didn't. And that so we were hopefully gaining access to the diurnal cycles so that we could at least smooth out our data usage. And then on the launch of Japan on the 21st was really our mark, and that was we wanted it to be absolutely smooth, and it did. We had 0 problems when we launched Japan, and people have talked about as a small company, our entire company when we launched Pokémon GO had probably 70 people in it. There's no way that I could have managed a data center. There's no way I could have managed the infrastructure necessary to do all of this work. And having the Google team on the other side provisioning resources for us to support the load that we were throwing at the system, and having a robust enough environment that it just did not fall over. We had absolutely no problems with Datastore during this time. We kept running out of quota, but Dan took care of that for us. So this is kind of our launch, and that's pretty much it.
Yeah, that was definitely a fun ride. That was fun to be involved with. I know it was also fun for a lot of people on our team to see this sort of request, and when I'd come with them and ask, okay, I think we need to add this amount to the system, and they'd ask, did I get a 0 misplaced on that number? And it's like, no, we really need that, like, now. So that, I think, is a prototypical example of where we find the real success stories with Cloud Datastore. It's you want to build something and you want to spend time on your application, and you really can't afford to either hire people or take people out of what they're doing to manage this underlying infrastructure. You just want to be able to use it and have it taken care of by someone else. And we are very happy to take care of that for you. Having said that, there are definitely cases where Cloud Datastore really isn't the right solution for you. And I will be the first person to tell you, if you're talking to me, whether you should be using Cloud Datastore or you should be using a different product. So just to give you a very high-level view towards the end of the presentation here, is when you wouldn't want to use Cloud Datastore or when other solutions might be better. Now, people definitely use it in this way, and that's perfectly fine. There are going to be gray areas when you work on your application. But this is a little bit of a cheat sheet to think, am I using the right product for this particular solution? And the first one that I want you to think about is, are you really looking for that 0, 1 millisecond latency, maybe even 3 milliseconds latency is acceptable for you? You really need to be looking at some sort of in-memory cache to sit in front of your database. Very often we find people within the database user group will have caches sitting in front of the most latency-sensitive data and use it like a write-through cache. An example of here is you could spin up your own Redis instance or Memcache instance, or if you happen to be using App Engine, we provide a hosted Memcache solution that you can use there if you want hands-off in that aspects as well. The second one, and I talked about this a little bit earlier, is if you're really looking for analytics. Like if you're a business department that's doing lots of reporting every day, multiple times a day on the data, we're not going to be a great solution for that. We want to give you queries that scale with your operation. We talk about it in terms of scaling with the size of your result set rather than in your data set. So if you query for 10 records and you have 100 records in your database, we return in the same time whether you have 100 million records. Now, we can't provide those sort of guarantees when we have complex joins within the system. So if you're looking for something like that, take that export experience I talked about before into cloud storage and then bring that into BigQuery, and that will be much more cost-effective and much more flexible because you can use that standard query language. The other one is if you're doing a more operational database on your analytics, you're doing that mixed workload where you've got transactions and payment systems coming in and you're continually running these join statements over it. You probably don't want to use BigQuery for that. What you'll want to use is something like Cloud Spanner, which is that horizontally scalable relational database. Now, Cloud Datastore can do some very extreme loads, but there are some situations when you're talking about extreme loads where we're not going to have the right trade-offs for you. We put transactions on top of it. We have multi-region replication. If you're doing things like Internet of Things devices, so if you're doing a jumbo jet where you have sensors all over it and you're streaming 300 terabytes of data at very quick rates, you want to look at something like Bigtable that is specifically designed as a zonal system to do this huge ingestion of essentially a wide column store. The other one that I commonly see is someone who wants that pure lift and shift solution. They want to take the existing solution they have on-prem and just move it to the cloud. They don't want much else to change. Maybe they don't want to have to worry about the underlying hardware infrastructure or OS updates, but they want the database exactly as it is today. Like, we're not going to be able to provide that for you. So that's where you look at things like Cloud SQL, which give you MySQL and Postgres support. So you can pretty much take your application as it is today and shift it into the cloud. And before we go into the Q&A, I want to leave you with some next steps that you can do after this session. The first one is, as I mentioned before, it is super simple to get this really complex data system up and running. Go to the console, console.cloud.google.com, create your instance. You can actually use it for free. I think we do 50,000 reads per day is a free tier, 20,000 writes, 20,000 deletes per day, and 1 gigabyte of storage. So you really can play with it and not have to worry about being charged. You can check out our documentation if you have technical questions. Myself and a bunch of engineers are quite frequently on Stack Overflow, so you can always use the Google Cloud Datastore tag, and one of us will most likely see it and be able to give you a quick answer to your problem.